Okay, welcome back. My air conditioner is going a bit in the background school. Hopefully you can hear what's said. I'm going to keep moving with this video series. This is kind of a series of scripts. You can see 4 here that are playing off of transformations of find and how to get those up and running. Let's see what I ended up doing with it. Let's turn everything off except what I've selected. And basically, transformations of find are some things that you may or may not be familiar with. But I do like them as components, and they do some pretty nice stuff. So let's take a look at what we have. Right here we have scale the range in series. Scale with ranges in series to consider center points. Consider linking all your parameters to avoid collisions, and reduce the need for Boolean operations, which I'll do later. So I've run it through a range domain of 0 to 12, which is default. I've thrown this through a sine and cosine. You can imagine I'm building a staircase. Which is what so many people do, and I've been put on a Nernst curve to that, and I divided that curve once again. I did that so I could articulate some vectors within there, and I've just got to grab a little more of a zoom extends all. What I have going on here is something a little tricky, probably because I have too many scripts open. Let's take off these, and you can see that it's pretty jazzed up with information. Let's jump back in there and see if I can't just grab that one. And if you're ever getting stuck like this on layouts, maybe do a 4-point layout, go back in, and I have to wonder why I'm just not zooming. I'm in a render, I think I'll go back into shaded. Very tricky what's happening here. A little bit of a pain. If you ever run into this problem, just I'll get rid of my old file, we'll start a new file, opening a new Rhino window, and zooming extend all. There we go. Now I've got a little bit. It was just sticking from a past project. But you can see that I've gone in there, produced a helix. I've undivided the curve by a certain amount of counts, 32, so I can make as many as I want or as least as I want. And I put some vectors on there to show the pattern of where that's moving tangential to the curve. I've aligned the plane throughout that. And once again, when you see a model and maybe the planes are a little too big, go in the plane area. Plane size you might want to reduce. I'm going to reduce it down to size 4, hit enter, and now I see I have a nice little system of what's oriented. What I then ended up doing with those planes is I built a bounding box, and I deconstructed that, grabbed certain faces on it. This is sticking. I think it's my mouse that's sticking. A centroid that I can do an orientation, and I can grab those bounding boxes, use those planes, and orient those boxes onto it. I can scale them differently if I want, and have a little bit of control 1 and shrinking them down if I so choose, and there's a scale non-uniform. My sole point of that was to use a pretty familiar spiral staircase to get you thinking about you're not just stuck in the regular scale, you can end up going in there and using the scale non-uniform components. One thing that I do want you to notice, this outputs a transformation as well. So if we take a look in for this transform node, what is actually being outputted as data, and how can that be visualized? Let's see what ends up coming out. Any transformations, those are the scales and the details of what's happening on each one just by one. But I'm going to go in here and take a look at transformations, maths, matrices, transpose, construct matrix, swap columns. No, it's not construct columns. Where am I going to find this? Transpose matrix, display, matrix display, multiple matrices. Got my head into something that I'm not really, I'm not visualizing it quite yet. Probably have to play through displays and think about what I'm doing. Previews, graphics, tags. Now, my mind's wandering right now, and I haven't caught up to myself, so just give me a minute on this. I'll probably be able to articulate what I'm doing in a minute. Let's turn that to disable, and let's go ahead and see our next one, projecting and projecting with direction. What did I so choose to do in this script? Let's take it all and put it to enable, and we're seeing a much bigger component of what's being decided. What are the geometries that are happening here? Let's take a look at a peek in here once again. Take off your ungroup, and I had gone in and created a sphere. I also created a quad sphere. So I have a sphere and a quad sphere. Quad spheres give you beautiful edges. Let's do in and see what we have going on, because I'm going to be using that later on way over here. as these geometries start to move and be put to a surface, and I'm starting to realize what I'm doing. I'm grabbing that sphere, I'm evaluating the surface to multiple points within it, so I can end up having all of these planes that follow that pattern that I had. That's pretty sweet. And after I found those points on the plane, I did a plane normal to assess a plane, an aligned plane that will work to get my planes in order. I wanted my planes to be normal to the surface of where they're evaluated on that sphere. I wanted to put on a bunch of wonderful geometries that I have a huge radius, and I wanted a boundary surface within all of them because I wanted the surface to give me a plane. Probably didn't need to do that, but I did it, and then I projected these objects off towards that direction. It's kind of nice because it's a three-dimensional object made two-dimensional to make a pretty interesting line pattern. I like this creative script. It's mine, and this is the type of stuff that I like to see people play with. They start getting their head around wiring these components together. I'm looking at the normals of what direction I'm going in. I'm projecting along those planes, and I'm pretty sure I threw it into a subdivision. So the first one, which is this, I put it into a subdivision multi-pipe to produce this geometry, and then the subtlety of taking this one, which is actually using a very similar projecting along versus project to give me this one. So actually I have two different geometries that are here that are behaving a little differently just because of the similarities and differences between the project and project along node. So once you get in the habit of using certain primitives and you understand them as curves and surfaces, it's why I like the quad sphere so much, because it gives you so much more information than a sphere, and you can break it down. It's kind of like deep repping a box to gain access to it, and it also gives you some pretty nice curve geometry and gets things out of the X, Y, Z. So I'm going to take that and just put that to a group. I'm going to roll that back into color. Like I said, put it to a color that you're happy with. Let's take a look at a bit of a fun with camera obscura, orient direction and path mapper. Let's put that over to enable. Let's take this off ungroup and see what I ended up doing. Once again, let's jump in here and see what's happened. And it's pretty, XYZ. Let's see what I ended up doing. So I ended up making a domain box, and that domain box is pretty sweet. I've got my X and my Y running through the same positive and negative direction, so I can center it on the XYZ. And of course, this is jumping around a little bit. I'm going to go in here. One thing to center this, which is nice, is just go in. If your Grasshopper is misbehaving in the Rhino environment, bake it. Go in and grab your standard toolbar, zoom extend that plate, and that will pretty much set it up in a little more controlled fashion getting at it. You'll end up wanting to delete that, but at least you have a little bit more control over moving through the window. I also took another range. Well, I moved that, and I moved it up. And I found the center of that point, and I grabbed a camera obscura that I can take this object and throw it through this range of a factor, which has 8 components. So I'm actually obscuring that through the 0 point. And if you think about your early photography, what's actually happening is it made a series of this kind of passing through the focal point and then appearing mirrored on the other side. So you're starting to swap all the direction of the lines. It's going to affect lofts and curves differently, something to think about. And I've dispatched and grabbed the start line direction from this. I've turned this one off for some reason. Not sure why. Let me, probably didn't select it when I was there. Let me take that to enable. And I've got 2 lines here, this one and this one. The camera obscura up in the top starts to obscure back. So that's interesting, a double camera obscura. And I'm able to orient the direction on that and start to produce this pretty interesting geometry. And so a little bit of control there. I jumped into my path mapper. Looks like I did some flattening, null mapping. If you don't know what you've done, it's sometimes good to go back into sets, grab your tree data, grab your path mapper, plug in your data, take a look at the null mapping, what you're dealing with as a system. I basically just put on my elements at the end of it. I put on how many items are at each list, and I trimmed back my tree from B back to A and tucked A in there. And then I swapped my B with that. So I ended up with these shapes, and I ended up with these shapes. So it's a little bit of geometric control through the path mapper and understanding paths and what's being selected. If you're not familiar with the system of going in and manipulating it, There are some really nice videos. I've made some myself, but BIM Corner is fantastic. Mode Labs is another one. But starting to control from this, what would I want to gather from there? And actually, I wanted to gather these two sections. So I had this data and this data that I can end up printing. Maybe, I guess maybe I did it because I wanted all these on one list, and I wanted all these on, one layer, and all these ones on baking on another layer. And that way I could render them differently. Selecting this group, selecting group, and then this one I can select this group. And then if I chose one transparent or one inlaid or one boolean, I could play with that back over in Rhino. Also, the whole point of this is to play with the camera obscura. Probably not too many people online have played with a double camera obscura, the Drusid geometry. It was just something that popped in my head while I was doing it. Well, what if I shot it through a focal point and then reflected it back through the same focal point? That might be kind of interesting. And if I can hold that image on, what happens when I start to play with the size and scale of this? How fast is the script? What does it do? And I put it into integers as a domain value. And I have another number slider here that can start to break it up into, I have to follow my number slider to a multiplying factor on the motion. And then I've got a domain set here that I can scale smaller and larger. And I have my steps in case I want to play it out or have less so. So just a nice way to make a pair. This could be tucked into a double obscura, domain box component if I wanted to, but I don't think anybody would be interested in that in the plugin. But that's how I end up learning and moving through this. It's a little chaotic today, but I just got done teaching. I haven't had any lunch. My head's a little frazzled, and I'm about to have a meeting with MGSM in 45 minutes. So busy day, and I'm just plugging through, making videos to show you all this is up and running. Get in here, play with it, dissect it, reverse, kind of configure what's happening, and play around with the parameters to build your own geometries. That's about it. I'm going to group this and take it back into my color that I prefer. Like I said, I hope my air conditioner isn't too loud. Let's see this last area. Mapping is a good way to orient complex and simple geometry. So why did I write that? Let's find out. Let's enable all of this. Let's go in here and ungroup, and let's see what type of thing we have going on. I have a bunch of triangles here, which are probably parametric three-sided polygons. I have this cone, or maybe not, and then I have these circles. So what's being created from this system, and how did I end up making it? So let's roll on in and say, okay, basically started with a cone. I put a bounding box around it per object, which could be union box because it's just one object, so it doesn't matter. Box map it. We'll take that and take this object and this bounding box and map this box to that box, map that object to that object. And that's basically what you've got going on in box mapping, and you end up with a geometry. So that's it. I haven't used it much. I haven't done much with it. Let's jump off here, and like I said, it's a three-sided polygon, but you can amp that up and do whatever you want, but it does fault out on the second part of the script. So you have to be careful with Grasshopper sometimes because it all upstream could affect what's downstream. It might bust your script if you play around. So I took that and I put a bounding box around it, which is more of a region bounding box or a 2D bounding box. I deep rep that to get at the faces. There's only one face. That's the source. The target is to go in and say, here's a circle that I did as a polar array bounding box and put a deconstructed rep. And I've rectangle mapped this geometry from that source to that target and ended up with that. This is great for actually moving geometry, organizing rooms, mapping geometries. Say you have an actual room set up. I think I saw it used in the robotics lab this summer to actually move things around and avoid collisions and things like this. But certainly learn how to map things. A triangle mapping is probably very similar because that was a rectangle box mapping. What is it asking for here? A circle, a geometry. That flows up to the top. This one's grabbing this circle as a geometry and mapping it over to this polar array. And what is the difference? The difference is you get these geometries and this one, radius on the hex, the points on it give me this geometry. So pretty interesting from circle. Not too much different. Triangle mapping all the way through to rectangle mapping. But produce my, well, you see a little difference in here where the object's located and where it ends up going. Can't say I use those notes too much, but mapping is a good way to orient complex geometry with simple geometry. All right, and you do have some pretty nice models and maquettes and things made just from this script in and of itself. And you may find that a 12 or 20 node script produces something worth going in and just overdoing it with a bake, leaving Grasshopper, jumping back out into Rhino. You've got this, that this might be a good place to start with how I would build something. And I think that is the power of flowing back and forth, whereas somebody thinks you have to learn all about Rhino before you can play around in Grasshopper. I came in completely reverse. I've taken more of an interest computationally in precision control through Grasshopper so I can run Python and C scripts and user objects. But this is a nice system that top down, like a top plan. That's not bad to think about grouping these, like possibly the circles, and starting with what I might want to use for geometries. And that's all. That's a little bit of curves, and that's a little bit of surfaces, which is basically what Rhino's so good for. And I do like this plan over here. It's kind of turning into something I actually might turn into a project. Anyway, 16 minutes of kind of rambling on about a script. I'm going to go into 34 and keep you up and running all of your nodes and components in the vanilla or ribbon tool components for Grasshopper. Thanks for watching. Michael Wickerson here.